Alright, moving right along. Again, precal 10. This is 2.5, the sine ratio. We're also going to include inverse sine in this as well. So, quick review of normal sine ratio. I didn't give you guys enough information here. Let's go with 12. So, whenever you're solving this, again, always label everything first. So, based on our main angle here, this is our opposite. This is the hypotenuse. We're going to try and find the hypotenuse. And this is the adjacent. Again, we don't really care about the adjacent because we're looking for the hypotenuse and we know the opposite. So we know we're going to use our sine ratio. So again, really quick, sine theta equals our opposite divided by the hypotenuse. When I fill this in, I know I'm dealing with angle 60. So sine of 60 degrees, so sine 60, equals my opposite, which happens to be 12, divided by my unknown. Again, if you know the shortcut, awesome, go ahead and do it. We're going to go and do it the less shortcut method, just so everyone kind of knows what's happening. So I'm going to times both sides by my unknown to get it by itself. This then turns into unknown times sine of 60 equals 12. But unfortunately, unknown is still not by itself, so I'm going to divide both sides by sine of 60. And that should isolate and get our unknown by itself. So our unknown is going to be 12 divided by sine of 60. Now, there's two ways to do this, depending on your calculator and what you kind of want to do. If your calculator, you're worried about it not giving you the right answer, you can type in sine 60 first and go 12 divided by 0.866025. As long as you keep 5 or 6 decimal places, the more the better. You should get pretty accurate. Do not round this. If you rounded this to like 0.87, let's say, and went 12 divided by 0.87, that gives you 13.79. If we divide this by sine 60 exactly, we're off by a couple of decimal places. And depending on the teacher, depending on where you're at, significant figures or significant digits are very important. So for our situation, if we keep as many as we can by sine 60, we know our unknown side is going to be 13.86, I believe it was meters. If you round at the very end and nothing in between, you should get the most accurate answer possible. Again, that's just a review of the sine ratio. By this point in time, you should be pretty well understanding it. We're going to talk a little bit about inverse sine ratio, and we're going to talk about it first with sine, and then in tomorrow's lesson we're going to talk about it with cos and tan. It's kind of like everything else. Once you've understood it for one of them, you understand it for both of them. And for this, we kind of really have to look at our calculators. And hopefully this shows up with enough clarity. So, above each of our sine, cos, and tan functions, we also have sine -1, cos -1, and tan -1. Those are what we call our inverse tan functions. And we use those when we're trying to find an unknown angle, but we know two sides. I really want to stress this is not the same thing. I know this calculator, I can put -1. So if I go sine and then put -1, that is not the same thing as if I put inverse sine. Notice how the -1 is outside of that bracket. This is what we want. So, when dealing with inverse sines, you approach it the exact same way. First step is always going to be to label your triangle, but now they want to label the triangle based off the angle you're trying to find. So this is still the longest side, so this is our hypotenuse. This is our opposite, and our top will be the adjacent. We know we have to use opposite and hypotenuse because those are the only two we know. So again, we pick our formula. We go sine theta is this equals opposite divided by the hypotenuse. And now you want to fill in your formula and solve. So we're going to go sine, we don't know what theta is, so it's going to be sine theta equals 48 divided by 70.38. At this point in time, we realize that you could leave it as a fraction if you want. You can calculate out the value. The only issue is it's going to be a very large number, which isn't super nice. When we take our inverse sine, it takes this ratio and turns it into a angle. So what you're going to do is when you hit sine -1 on the calculator, so sine -1, we take inverse of it. What it does is it swaps out your theta with the opposite and the hypotenuse. So really it turns into this. And it basically equals your theta. So what you have to do is then swap out everything here with that theta. So when I plug it into my calculator, I'm going to go inverse sine, so sine -1. I'm going to put 48 divided by 70.38. I'm going to close my brackets. If you had just kept that long decimal, you can plug in just the decimal if you want as well. But when you plug that in, it'll say, hey, look, it's exactly 43 degrees. So I know that my angle is 43 degrees. Again, it is very important you keep your calculator set to degrees here in the bottom, because if you have it in radians or anything else and you try this out, it's going to give you very different answers. And just to double check, hey, look at that, we were correct. Okay, we'll try one more example just so you guys fully get the hang of this. Again, inverse, once you get the trick, it's kind of like all the other trig functions where it just becomes pretty straightforward. You just follow the steps. So step 1 is always going to be label your triangle based off your angle. So we have an opposite, we have an hypotenuse, and we have an adjacent. You pick the corresponding formula. Opposite hypotenuse, we know we're going to deal with sine. Sine theta. In fact, if you want to go one step further, you could even rewrite this as inverse sine. So I already know that I'm going to swap out the opposite and the hypotenuse with that theta. So inverse sine really becomes this. And I can then fill in my formula. So sine -1, opposite, which is 75, divided by my hypotenuse, which is 90, equals my theta. And when I plug it in my calculator, making sure I'm using the proper inverse, so 75 divided by 90 gives me an angle of 56.4 degrees. The nice part about the inverse functions is there's not a whole lot of algebra involved. It's a lot more plug and play and solve from there. Alright, your two questions for this section, 2.5. Question 1, we have a triangle. The angle is 25 degrees. This side is 21 meters, and you have to find this length. Again, this is actually very similar to the very first section we learned. It's not too difficult. Question 2, however, you have to use the inverse function. You're trying to find this angle. This side length here is 84 meters, and this side length here is 40 meters. And like always, again, if you're going to go into Precal 11, I strongly recommend more practice is better than less. But again, the homework questions down here will not be for marks. But if you want more to do, on page 101, questions 3 to 5, and question 10. Good luck.